Hello friends, this video on thermodynamics part 3 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched part 1 and part 2 before going ahead with part 3. Now we will start with the topic. In this chapter we will mainly concentrate on thermal equilibrium. Just now I told you in the previous slide what is thermal equilibrium. It is nothing but it talks about uniformity of temperature. That means two systems are said to be in thermal equilibrium if they are at same temperature. So let us see. Two systems are said to be in thermal equilibrium if the temperatures of the two systems are equal. Right? A system is in thermal equilibrium or not depends on surrounding. It also depends on nature of the wall separating the system and surroundings. So, thermal equilibrium, as I told you, it means that both the systems, two systems are in equilibrium. What do I mean by temperatures of two systems are equal? That means the temperature of a particular system is not changing with time. The temperature is remaining the same. So, what are the factors on which it will depend whether the temperature of the system is changing or not? It will definitely depend upon the temperature of the surroundings, right? For example, let us think of this example. I have some hot water in a glass. I kept it on the table for 1 hour. What happened? After an hour, you will see that the water is no more hot. It turned cold. Why? That's because the temperature of the water was very high, whereas the temperature of the surroundings was comparatively low. So because of which transfer of heat took place from body at higher temperature to body at lower temperature, and as a result the temperature changed with time, right? So whether a system is in thermal equilibrium or not, how the temperature of the system will be, whether it will be constant or it will change, it depends on the temperature of the surroundings, and it also depends on the nature of the wall separating the system and surroundings. For example, you would have seen at your homes that generally your mom, when she prepares hot tea or hot coffee, she prefers to keep it in a thermos flask. Why? Because if you keep it in a thermos, the hot tea will remain hot for a longer time. That's because the wall of the flask is quite insulating. It doesn't allow the heat to flow across it. Therefore, the temperature of the coffee will remain hot and it will not allow the heat to flow out of the flask. So these are the two things that will determine whether a system will have constant temperature or not. And if the system has constant temperature, then the system will be in thermal equilibrium. So I hope you understood that what is thermal equilibrium and how does it depend on surroundings and the nature of walls separating the system and the surrounding. Now, having said that the nature of wall plays an important role, let us discuss this in bit detail. The example which I took just now, hot coffee in thermos flask, let us talk about it in detail. There are two kinds of wall basically. One is adiabatic wall and the other one is a diathermic wall. What is adiabatic wall? Adiabatic wall is is a kind of insulating wall. Adiabatic wall is insulating wall. That means it doesn't allow heat to flow across it. So if you separate two systems by an adiabatic wall, then this wall will not allow heat to flow from one system to another. So let us suppose we have two systems A and B which are separated by adiabatic wall. That means the heat will not flow from A to B or from B to A. So let us suppose if A is at some temperature T, and B is at some temperature T dash, their temperatures will not change with time because heat flow will not take place from one system to another. And if there is no heat flow into the system or out of the system, there will be no change in temperature. So that means the temperature of both these systems will stay constant with time, right? Here we also assume that both these systems are separated from the surroundings by adiabatic wall. That means not only the wall between A and B is adiabatic, but also this boundary. That means the wall between B and surrounding and A and surrounding is also adiabatic. So that means no flow of heat into system A or out of system A is taking place. Similarly, there is no heat flow into B or out of B. So therefore, temperature of both the systems will remain constant. So in this case, we can say that any system, let us suppose if this system A is at some pressure P1 and at some volume V1, and this system B is at some pressure P2 and some volume V2, that means any gas which is at some pressure P1 and some pressure and some volume V1 will be in thermal equilibrium with any other gas at some pressure and some volume if they are separated by an adiabatic wall, because no heat flow will take place, therefore there will be no change in temperature involved. So one practical example of this would be your thermos flask, because in a thermos flask the wall is an insulating wall which doesn't allow heat to flow through it. Now let us talk about diathermic wall. Diathermic wall is a conducting wall. That means it allows heat to flow across it. So now let us consider the same systems A and B are now separated by a diathermic wall. So since it is a diathermic wall, that means this wall will allow heat flow from the systems across each other. Right? So heat flow will take place between these two systems. Let us suppose if system A is at a higher temperature, say T1. System B is at a lower temperature, say T2. So what will happen? Heat flow will take place between the two systems. Not only temperature, we are talking about any macroscopic quantity as a whole. So since the wall is conducting, the macroscopic quantities will change their values. Let us suppose if system A was at some pressure P1 and some volume V1, system B is at some pressure P2 and some volume V2. After some time, the pressure volume will keep changing because both of them are at some different pressure, some different volume and some different temperatures. So that there will be some flow of heat between the two systems till the time they both reach the same temperature. So that means there will be some flow of heat taking place until the system reaches the state of thermal equilibrium. So what did we see here? We saw that what is thermal equilibrium, what are the factors on which thermal equilibrium depends, and how is thermal equilibrium in case of an adiabatic wall and in case of a diathermic wall. In case of adiabatic wall, any two systems will always be in thermal equilibrium because the temperature will not change. Whereas in case of a diathermic wall, the systems, there will be flow of temperature or flow of heat between two systems till the time the system attains the state of thermal equilibrium. So for this we can take the example of hot water kept in the glass. So if you keep it in the glass, there will be change in temperature or change in, there will be heat flow till the water reaches a temperature which is equal to the temperature of the surroundings. Like initially your water is hot. After 1 hour, the water is comparatively cold. Even after 2 hours, you will see that the water is at room temperature. And after that, it doesn't happen that the water goes to even lower temperature. Once it reaches the room temperature, then it remains steady at that temperature. That means once it reaches the state of equilibrium, then there is no further heat flow which takes place. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.